Hi, welcome to my new YouTube channel. So, the idea here is I wanted some space where I'm able to freely explore new things that I want to study. I just want to be upfront about this that something is not right, if something is not very concrete, it's because I am trying to learn things as I make these slides and as I try to make these videos, right? So I just want to set that expectation, and I hope that this works out to be something that sort of catalyzes further learning both for me and for you if you're watching it, right? So, okay, without much ado, let's dive right into the first topic that I wanted to cover, right? So, I had Cursor built me a new I had Cursor build me a new ingestion service. So what this does simply is that let's say I have a service which receives, let's say I have a producer service, right? Let's say this is something that ends up writing Kafka events, right? Uh, Based on whatever conditions, right? Let's make this guy into black. Okay, let's say this guy, he sends out some Kafka events with a topic, with whatever topic into, so let's say this guy sends out this event to this other service. And let's just say, for example, that this is a user event, right? So let's say every time uh, a user logs in or a user makes some edit or something like that, some user action is performed, right? So let's just say user action is the name of the Kafka topic, and that event gets consumed by a consumer service, right? So what I wanted to do is I just wanted to have a fake producer and a fake consumer, and I wanted to have both of these guys act in sync. And right from here, I wanted the data to go and get dumped into OpenSearch index, right? OpenSearch uh, index. So I just had an LLM code up this setup for me with whatever diagramming that I gave. And I had to generate this repository, and in this video, we're just going to go and explore what it has done, right? All right, so let's get started. And to start off with, we have the Docker compose.yaml. Has some slides. We could cover that first. Uh, so yeah, let's just call this our mini ingestion service because it is essentially ingesting Kafka events from the producer service and storing it into the index, right? Now, why are we exactly doing this, right? So when you're streaming events and you're receiving like a high volume of events, right? And it's not very feasible for you to have them stored in your database or somewhere and have it in a very read compatible manner, right? So when you have it in a read optimized index, right? So what that allows you to do instead of just having them stored in SQL is that you can have a lot of different kinds of search functionalities built on top of OpenSearch, right? And like features like, let's say, searching for products through your this thing through the Amazon catalog, or let's just say searching for some specific kind of user information or something like that, right? Whatever it is that you're looking up, when you have these, most of these data are stored in indexes, and it really helps to be able to ingest things faster into your index, right? So, so in this particular example that I told you, we are going to be using a Kafka topic called user events, and this is going to be the topic that we write to, right? So for in case Kafka is something that you're not very familiar with, just think of it as a message, a message broker of sorts. And the difference is that once you write a message, it gets stored to the a file. It's file-based log, and it's immutable. So once it gets written to the document, then any further reads it is not deleted on read, unlike your MSMQ or something like that, right? So uh, it stays there in the log, and only the only the marker saying where you have read it is updated, right? So you can do things like in replay and etc. on top of that, right? So, and for the schema contract in this particular project, I have ended up using this guy, right? We have an Avro schema, and instead of storing the contract or the schema, right, as a .NET entity itself or as a JSON file or something like that, we are storing them as an Avro file here. So we have the namespace, which is just something here, and com.mini.pipeline, and then we have the user action, the user event, right? It has an ID associated with the user, whatever action they have taken, and then some kind of a timestamp associated, right? As to when this user event was performed, right? So now, what this contract does is that it serves as the bridge between what Kafka uses to serialize and create this user action event, how it gets published, and also how it ends up getting consumed by I mean, it is basically an agreed upon contract between the producer and the service that I would send you the data in this particular format and you read it in this particular format. Now, why exactly are we using Avro schemas instead of just using them in JSON, right? Using them as JSON documents, right? Avro allows for faster serialization, and it's just a relatively much faster way of doing things as opposed to using JSON. Uh, and then we have these two services implemented in .NET itself, right? One is just a fake producer of events, and one is just a fake consumer of events, right? So, uh, what do we have here in the Docker Compose file? We have Zookeeper, which is running on port 2181, and Zookeeper is like a cluster manager for your Kafka. And then we have Kafka in itself running in port 9092, right? And also we have the schema registry, which is also available as a package from Confluent. And we also obviously have OpenSearch in 9200, right? So what we are going to be doing now is let's get started by probably spinning up I think I should have it somewhere here. Let me see. Before that, right? Uh, okay. So just before we get into the actually running the application, so let me just quickly go and spin up Docker. Okay. And over here, I think the command is Docker compose. I should have it somewhere here. Okay. And now, as you can see, my Docker containers are running. I have Zookeeper, OpenSearch, Kafka, and Schema Registry all running. You can see them here, right? And what is actually going to happen now is that I am going to go to my terminal of choice, but it's definitely not the one within the editor. Uh, let's spin up. Let's go to CD. I mean, what did I name it as? Uh, let's go to first. Let's just build the solution, I guess. .NET build mini ingestion.sln. Okay, so we have built both of those producer and services, consumer services, and then we have CSRC. Let's go here to the event consumer and start this guy up first. .NET run. It's not this. Oh, looks like I can run it from the project root in itself, right? So let's just go .NET run and start the consumer service up. Okay, so this is going to consume the events from the user events topic, and it is going to be dumping them into these OpenSearch user events document, right? And now let's just go ahead and also just start up the other server, other service. So this one is going to be wait, .NET run minus minus project. Okay. So this minus and 10 is just a variable that I'm using to control how many events should get produced. So just starting this, so now 10 events would get produced, and 10 events got delivered to the queue, right? And as you can see here, 10 different user actions, like some, this is at the producer level, this was created, and it was published to the Kafka topic, and then these are being picked upon by the consumer here. And yeah, you've got these events being consumed and being dumped into your index. And we can take this one step further. We can also go ahead and inspect what is getting stored into OpenSearch, right? So coming back to the theory of things, so what just happened right now, right? The you go to my producer code, which is also linked to in the repository. I mean, under the in the video description. You should see that the producer first consumes the schema registry, and with that, it tries to use an Avro serializer, right, to to serialize the data that it wants to produce, right, into the into the Avro serialized format, right. So between the producer and the consumer, the data goes through in an Avro encoded format, right? So from here, what happens is it resolves schema with the registry. Uh, the schema that we stored here is resolved against the registry, and then after that, uh, Avro events are published to the Kafka topic, which if you go here, you can, within the producer, you can see it happening while the producer is being initialized, probably, right? So, right. So it is producing it off to this particular topic with the message that we have, right? Uh, the user events topic, right? And also, yeah. So then what the consumer does is that the consumer also fetches the same, we also have an input for the schema registry happening here. And this guy also reads from the same Kafka topic. And before he does that, from the he pulls up the schema registry, and over here you can see that the consumer is also configured to use the Avro de-serializer from here. Right, all of these I'm getting them from the Avro.generic package, right? And yeah, so this is mapped as the de-serializer for this particular consumer, and yep. So the schema is resolved from this guy, schema registry URL, and through this guy, I'm able to see that I can get the schema first, and then after that, I'm also initializing OpenSearch here. And then once OpenSearch is also initialized, I have a handler of sorts here. So until you cancel the event, it keeps consuming stuff from the consumer. And over here, you see that the to document receipt.message.value, uh, right, a document ID is constructed, and then over here you can see that uh, we are just dumping this. We're just indexing whatever response that I mean whatever event that we got from the consumer, from the producer, and storing them in the index right here. Right. So, uh, this is what we roughly saw right now. Is the same flow. And you can see that in our canonical schema, which is a user event.absc, right? Uh, we already walked over all the fields that we have here, right? And right. And so I think we covered all of this. Similarly, we also went through this thing, right? Now, yeah, I just wanted to spend some time also talking about why we are using Avro serialization here, right? Now, instead of a JSON message, which has a lot of additional fields and data that we don't really, and JSON is a very heavy thing to encode and transmit over network, right? So here, you can see that our messages will just have a whatever they get ingested, right? They have a schema ID, right? And the payload is very compact, right? And why do we use the schema registry using our instead of just using our file directly, right? So the only thing is like in a typical production environment, you want your producers and consumers to remain compatible with each other, even when the schema is versions are changed. So it's just version control for the schema document itself, right? So yeah, these are the commands that I use, and if you want to go ahead and see the ingested documents, right, you can just run this curl query. Uh, curl, I already have it here somewhere, right? So in 90 from 90 to 100, which is where if you go to a Docker container, you can see that OpenSearch is going to be running at 90 to 100, right here. So from you can see that I'm just going to run this, and as I expect, I would see the different user events that I publish getting dumped into this OpenSearch index. Uh, yeah, so that's it, and thank you for joining me on this video. I hope you learned something new.